How do we know the universe is expanding? What evidence do we have that the fabric of reality itself is stretching, pulling our familiar world farther and farther away from everything else? It might sound like science fiction, but there are actually three major reasons why scientists are confident that the universe is indeed getting bigger. And it turns out this isn't just happening now or even over the last few billion years. This has been going on for at least 94 billion years, and we think it'll keep up for billions more. The first piece of evidence comes from looking up. In the early 20th century, American astronomer Edwin Hubble noticed something weird was going on with the galaxies in the Coma cluster. Back when Hubble was making his discoveries, astronomers had already identified around a dozen or so galaxies near our own Milky Way. But when he looked at them through his telescope, he saw something very strange. All of them were moving away from us. Not only that, but the farther away they were, the faster they were all receding. Today, we have several space-based telescopes that can detect much more than just the light from distant galaxies. We can see details of their spectra, which is the range of colors of light that pass through filters. Each color corresponds to a different wavelength of light. The spectrum of an object's light can tell us a lot about its chemical composition and physical properties. For example, if an object has a lot of hydrogen in it, we'll see strong absorption lines at certain wavelengths because the hydrogen atoms are absorbing specific colors of light. Astronomers also use spectra to determine how fast an object is moving toward or away from us. This is called the Doppler effect. If an object is moving toward us, the waves of its light will be compressed, shifting the spectral lines to shorter, bluer wavelengths. If it's moving away, the waves will stretch, shifting the spectral lines to longer, redder wavelengths. So when Hubble noticed that all the galaxies in the Coma cluster were redshifted, he realized they were all moving away from us. This isn't surprising, since we're obviously in motion too. Hurtling around the galaxy with the rest of the Milky Way at about 250 kilometers per second, but Hubble expected that as he focused his telescope on a random point in the sky, he'd find some galaxies moving toward him and others moving away. Since there's no preferred direction in space, instead, he found that every single galaxy he looked at was moving away, and the farther away it was, the faster it seemed to be receding. What's going on here? Well, one way to explain it is to say that the universe itself is expanding. As it expands, the distances between galaxies increase. So just like when Hubble made his discovery, when we look at a galaxy far, far away, we'll see that it's moving away from us, receding into the distance, with the speed proportional to how far away it is. Now, the second piece of evidence that the universe is expanding comes from the cosmic microwave background. When the universe was very young, less than 400,000 years old, it was incredibly hot and dense. Photons, the particles of light, were flying around everywhere and frequently bouncing off of other particles. This is why light couldn't travel very far. The universe was opaque. As the universe expanded and cooled, these particles combined together to form the first atoms, mostly hydrogen and helium. Suddenly, there were a lot more free electrons floating around. And when photons collided with them, they were quickly scattered away. As a result, visible light couldn't spread evenly throughout the universe. It got trapped inside little pockets of space where matter was dense. But over time, the universe kept expanding and cooling. Eventually, those electrons found protons to combine with and form neutral hydrogen. Now that they weren't charged, the electrons didn't scatter light anymore. And after almost 1 million years, photons were finally able to zip around the universe unhindered. This made the universe transparent. And today, we can see this glow from the early universe all around us. It's the cosmic microwave background. Recent measurements of the cosmic microwave background have shown that the expansion of the universe is speeding up, not slowing down. That suggests that there must be some kind of repulsive force pushing everything apart. Scientists call this mysterious force dark energy. Dark energy makes up about 2/3 of all the mass energy in the universe, but we still don't know exactly what it is. However, without dark energy, the expansion of the universe would be slowing down under the influence of gravity, so it's clear that something is accelerating the expansion. That acceleration matches what we see in the redshift of distant galaxies. Okay, so we see distant galaxies moving away from us, and we see the afterglow of the Big Bang supporting this idea. But is that all we have? No, there's one more thing. We can look at the large-scale structure of the universe. If the universe is just expanding, we should expect the galaxies to recede from us at speeds proportional to their distance, right? Let's check that. In 2020, scientists used data from the Sloan Digital Sky Survey to map the positions of more than 170,000 galaxies over 10 billion light-years away. They found that the galaxies on the outskirts of the survey were indeed receding from us faster than those in the center. But they also noticed something weirder. Galaxies within 8 billion light-years of us were all moving away too. It's like the entire universe is inflating like a balloon. So we have 3 pieces of strong evidence that the universe is expanding. But wait, you might be thinking we haven't really explained why. Why is the universe expanding in the first place? Or more importantly, why is it speeding up? Fortunately, as of right now, we don't have a good explanation. It's one of the biggest mysteries in modern physics. However, the good news is that the next generation of telescopes will help answer this question. For example, the James Webb Space Telescope will be able to look back in time to see how the expansion of the universe changed over the past 10 billion years. That could help scientists better understand what dark energy is and whether it changes in strength over time or space. Scientists hope that this knowledge will shed light on why our universe exists in the first place, and why it's expanding the way it is. And speaking of our universe, do you ever wonder what's beyond it? Check out our video on the heat death of the universe to find out what might happen to the universe over the next trillion years. Thanks for watching.